Okay, so we're just solving these logarithmic equations. You can see at the top there's two different methods. We've done them both. The method on the left is taking the log of both sides. The method on the right is using the change of base method, or if you remember, we did the change of base rule on the log properties page. They're going to come up with the same answer. Honestly, after you try them both, you can just stick with whichever one you like the best. Everybody's kind of a little bit different. But this very first one, you'll notice on both of them, the first step is the same. To always isolate the base and the power. So in this case, the base and the power is already isolated. So you can move on to step 2. Just because it's on the left-hand side, I'm going to do the taking the log of both sides method. So that means I would write this as log 2 to the x power equals log 50. Now in this case, because this is the way this worksheet shows it, I'm using common log. But the whole reason that we're doing this, we've already done this. The whole reason that we're doing this over again is because we're doing it with natural log and log base e, which is log base e. But this worksheet doesn't do it that way. You'll get the same answer. It doesn't matter which one you use. But starting on the next worksheet that I'm going to give you in just a minute, we're going to just use natural log. And you'll see why we would make the choice to use natural log instead. But once you've written log on both sides, remember the whole point in a logarithm is so we can move an exponent down to the line. So this becomes x log 2 equals log 50. And remember, I'm solving this, so I'm just trying to get x by itself. So now at this point, all you have to do is divide both sides by log 2. Now that's your exact answer, log 50 over log 2, but you'll see up here that they do want us to do the decimal approximation. They put wavy lines because you're going to have to round, because logarithms generate sometimes really nasty irrational numbers. So log 50 divided by log 2. You do have to make sure when you do these that you close that parentheses on after the argument. So I get x is approximately 5.644. Everybody good? That's the taking the log of both sides method. So next I'll do the change of base method, but remember the first step of both of them is to first isolate the base and the power. So on number 23, in order to isolate the base and the power, I first have to divide by 20. Okay, so now if we're going to I'm going to do the change of base method, which would be this one. The next thing you're going to do is to rewrite it. We're going to rewrite our exponential as a logarithm. Remember, the base is the base, and the argument and the answer switch places, basically. So this becomes log base 1.5, because the base is the base, of 15 equals x. Now, I know that we all could alpha window 5 that and get the decimal approximation in our calculator, and you could, and it would be right. But you need to be able to write the exact answer, which is this piece, the actual fraction. So remember, you're going to use the change of base rule, which says that the log of the argument divided by the log of the base is going to be your answer. And that's what I can put in my calculator. And you'll get the same answer once you put that in your calculator that you would if you alpha window 5 did. I checked just to be sure. Alright, so we're just going to keep going and whiz through them pretty quick. Does anybody have a method they prefer? Y'all care which one you do? I prefer the right log on both sides method. I just think it's easier. So that's the one I'm going to do them real fast. And that's the method I'm going to use. But if you like the rewrite it and then change your base, knock yourself out. But I'm just going to whiz through real quick and answer these with writing log on both sides. Just don't forget, you have to first isolate that exponential piece. So you got to get the base with the exponent by itself. We get to number 25. You got something that looks a little bit different because my exponential is not alone up there. It's not just an x or just a number. It actually is x minus 2. So I am going to bring that exponential down to the line. So x minus 2 gets to come in front. Because it was all up on top, when you bring it down in front, it has to still remain grouped together. So that's why I put the parentheses there. Yes, ma'am. Yeah. So now I actually have to distribute the log into both of those pieces because of that x minus 2. It looks backwards because we're used to seeing distributive property the other way, but this log 4 belongs to that x and to that 2. So it's going to be x log 4 minus 2 log 4. And don't forget what the whole goal of all this is. We are trying to solve this, which means get x by itself. So I'm going to do as best I can to just isolate x. So the first thing I'm going to do is move the minus 2 log 4 over, because it doesn't have an x in it. So I'm just going to take this and move it across, and it'll be 2 plus 2 log 4. So now I have x log 4 equals log of 0.5 minus 2 log 4. And now I can divide by log 4. Okay, so now that whole big thing, all of this, is considered your exact answer. When you get to college algebra next year, you have to give your exact answer. You can't just give the decimal. So that is the exact answer. But now we want the decimal approximation, so I'm going to put that whole thing in my calculator. On these, because of the way the parentheses are and all that stuff, it really is easier if you just use your fraction bar. So I did alpha y equals and pulled my fraction bar up, and then I'll just type the rest of it in. And that's actually an exact answer. This doesn't really need squiggly lines because it's 2.5. Okay, so now you can keep going. On the next one, it's already isolated, the exponential piece. So again, I'm writing log on both sides because I like that method the best. Alright, now when I get to here, I have 3x log 1.5 equals log 72. Now remember, we're trying to isolate the x. So I need to get rid of the log 1.5 and the 3. And they're both there by multiplication. So in order to get rid of them, you're going to divide. You can do it all at one time. So I'm going to divide by 3 log 1.5. Because that'll leave x by itself. And just save myself a step of having to write it out again. So my 3's cancel, and my log 1.5's cancel, and leave just x. So that would be log, my exact answer would be log of 72 over 3 log 1.5. And I'll plug it in the calculator and see the decimal approximation. Good? Okay, so in 27, we're going to just isolate the exponential piece, and then I'm going to write log on both sides. Yes. Yes. Uh-huh. Bye, Sable. You're leaving for the day. Everybody good? I got 2.02. Alright. Keep going. I think this is easy breezy now. We did the hard one. 1.5, that was the hard one. have answers? Check and see how you're doing. You got the same things I got. I whizzed through real fast, so I'm not positive they're right, but. Anybody have any questions on this? Yes, sir.
On 28, wouldn't it be log 3 instead of 4?
Yeah, that's what I got.
Yeah.
1200.
Oh,
divided by
it sure
400.
would. It sure would. That's my fault. I probably did it in my head. Yep. Which means that this is a 3 and this is a 3, and so the answer is. Put 393. Everybody good? Okay, so I'm gonna look first at the back side of this page because it's very, very similar to what we just did, and then we'll talk about the front. It's like a little matching thing. So, but if you look at the back side, we're simplifying and solving exactly like what we just did. As a matter of fact, even at the top, it's got two different sides. And it's talking about the difference between being given a logarithm and solving for an exponential, and being given an exponential and solving with a logarithm. But if you look at number 1, it's almost exactly like what we just did. But the base is e. And because the base is e, it makes more sense to use natural log than it does to do common log. But you still have to isolate the base, just like we did before. So you're going to divide both sides by 20. And that gives me e to the x equals 4.5. Now, I am going to go in and write in, instead of log, writing log on both sides, I'm going to write natural log on both sides. So I'm going to write ln e to the x equals ln 4.5. The process is exactly the same. There's no difference. But there is a reason why we do it, and you'll see. I'm going to take this x, put it down on the line. That's the whole point in a logarithm. So now I have x natural log of e equals natural log of 4.5. Well, right here, everything gets a lot easier, because if you remember, if you have a base and an argument that are the same, if I have log base 6 of 6, what is that? 1. If I have log base x of x, that's 1. Well, this ln e is actually just log base e of e. The ln is just an abbreviation for log base e. So that means this piece right here, ln e, is 1. So you have x times 1, which means you already just have x. So x is the natural log of 4.5. That's your exact answer. And then you just plug it in your calculator to get a decimal approximation. Now, we could do exactly what we did just a minute ago. I could have divided by 20, written log on both sides, brought the x to the front, divided by, you would get the exact same answer. But because natural log of e cancels out, it makes it like one step shorter. So anytime you have an e in the problem, you're going to use natural log on both sides. So if you'll look, 2, 3, very much like what we just did. Number 4, still just like what we just did, but you've got more pieces to move in order for that piece to be isolated. Because I've got that 3 in front, we didn't do any that had those. The 3 and then the 15 has to be moved. 5, same thing, got to get rid of the 20. This one's one that you'll have to distribute, just like number 25. It's just this time, instead of distributing common log, we're going to be distributing natural log. But now if you look at number 6, this is where things get just a touch different. now I have natural log of 2x equals 5.5, and my x is part of my argument. So if you look up at the top, this is going to be like this sample up here. Instead of writing log on both sides and solving it, now we're going to write the e on both sides, and we're going to put the sides as our powers. So I'll rewrite this as e to the natural log of 2x equals e to the 5.5. And we have a power rule that tells us that if I have e to the log power, that means that this side is the power equals e to the 5.5. And then I'm just going to divide by 2 this time. Now that is your exact answer, e to the 5.5 divided by 2. You can put that in your calculator to get your decimal approximation. So in this case, instead of isolating the exponential piece for 6, 7, 8, and 9, you're isolating the logarithmic piece, but the process is still the same. Okay, real quick, let me flip over and give you just the instructions on what you're going to do on the front page. You are looking for, let me make sure I understand how the puzzle works at the bottom. 1.
Yeah, you match the number 6 with
Oh,
each letter of
At each column, that's what I thought, but I don't understand how they go.
one column R, column D.
Oh, I see how, okay, so I see how they go down. I'm trying to figure out how you plug it down in the bottom bit. You find the letter that goes with one R and it goes here, and then the one that goes with one D. Okay, so remember our log property rules. And if you look up at the top, you can just, and your log rules and your exponential rules. If you have if you have 2 bases and you're multiplying the bases, what do you do with your exponents? Add your exponents. If you're dividing the bases, what do you do with your exponents? Subtract. So if I have a base that has added exponents, then the reverse is true. So if you look at e to the x plus 4, that would be the same thing as letter number 1 would be the same thing in the middle column. My exponents are being added, which means my bases would be being multiplied. So that would be e. So my answer down here for 1 column R is going to be e. So I put it e. I should also have a decimal approximation. So they actually want me to work it out. Hold on, I'm looking. It would be natural log of... For sure do the back. Match as much as you can on the front. Oh, wait, it's Friday. It's not Friday, but it's Friday. Never mind. We'll do it Monday. We'll finish the back on Monday. I think some of the ones in the second column on the front